Let's talk about something that's happening all around us, all the time, but is completely invisible. It's like a secret dance, a dance that all matter is doing. We're gonna dive right in. I mean, have you ever really stopped to think about it? Why does a shaken soda can explode? And how does the smell of your morning coffee manage to get all the way across the house? These things feel so different, right? But what if I told you there's one single powerful idea that explains both of them, and so much more? Yep, that idea is the secret choreographer of this whole invisible dance, and it pretty much runs the show for, well, everything. And the big answer? It's a thing called the kinetic molecular theory. Okay, I know what you're thinking. That sounds super complicated, like something from a chemistry final. But stick with me here, because I promise you it's way simpler than it sounds once we pull it apart.
So, let's get to know the stars of this show, the moving molecules. We're going to decode that big fancy name right now.
All right, let's break it down. First up, kinetic. That's just a fancy word for motion. Easy enough. Then you've got molecular, which, you guessed it, is all about molecules. You know, the super tiny particles that make up absolutely everything. And finally, theory. That's not a guess. In science, it means a solid, well-tested explanation. So we've got motion, particles, explanation. Let's put them all together.
And there it is, the kinetic molecular theory. All it's really saying is that everything in the universe is made of tiny particles. And here's the crazy part. Those particles are always moving, constantly, nonstop. That's the whole secret right there. Everything you see, touch, and breathe is secretly just jiggling and bouncing around.
Okay, so this whole idea really boils down to 3 core rules. Rule number 1, everything's made of tiny particles. Got it? Rule number 2, these particles are always on the move. They never, ever stop. And rule number 3, and this one is the game changer, temperature is basically the speed control. Think of it like a gas pedal for these particles. You turn up the heat, they go faster. You cool things down, they slow right down. Simple as that. So now that we have the rules, let's put them to work. We're going to see how this totally explains something you already know: solids, liquids, and gases. This is where it all starts to click. Check this out. In a solid, like an ice cube, the particles are cold, right? Low energy, so they're all packed together, just kind of vibrating in place. Now let's add some heat. That's energy. They start moving faster, breaking free a little, and you get a liquid. Now they can slide past each other. And if you crank up the heat even more, you get a gas. Now those particles have so much energy, they're just flying all over the place, totally free and super fast. So just imagine what's happening inside, say, a balloon. You've got all these super high energy gas particles just ricocheting around like crazy. They're bumping into each other, slamming into the sides of the balloon. We're talking millions, even billions of tiny collisions happening every single second. It's absolute chaos in there. And all of that slamming, that constant pushing against the container from all those tiny particles, that's what pressure is. It's not some weird abstract force. It's just the combined might of countless tiny collisions. So next time you check your tire pressure, remember, what you're actually feeling is trillions of little air particles hammering away at the inside of that tire. How cool is that? But look, this isn't just stuff for a science lab. This invisible dance is happening in your world, right now. Let's look at some examples you'll definitely recognize.
Remember the coffee smell? Same thing with perfume. Those scent particles are just zipping through the air until they reach your nose. That's diffusion. Or a balloon in the hot sun. The heat speeds up the air particles inside. They push harder on the balloon, and poof, it expands. Ice melting into water? That's just the particles gaining enough energy to break free and start sliding. And why do your car tires seem flat on a cold morning? The cold slows the air particles down. They don't push as hard, and the pressure drops. See? It's everywhere.
So if there's one thing to remember from all of this, it's this simple sentence. Everything is made of tiny moving particles, and temperature controls how fast they go. That's it. That one idea is the key to understanding so much about the physical world. Which brings us to one last question for you. Think back to that shaken soda can. Now that you know all this, what do you think happens to the motion of those particles and the pressure inside if you take a sealed container of gas and heat it up? The answer is, well, it's pretty explosive. And it's exactly why you don't want to leave a can of anything in a hot car. Something to think about. Thanks for joining me.